First, I'm going to go over the answer the textbook is looking for, and then I'll explain why I disagree with the textbook answer. This question has two parts. It's asking us to calculate the error and the percent error. To calculate the error, we're going to take the experimental value and subtract the accepted value, or the true value. So in this problem, a technician is measuring the boiling point of octane and measures that to be 124.1 degrees Celsius. The actual boiling point, or the accepted boiling point of octane, is 125.7 degrees Celsius. So 124.1 minus 125.7, and we get that the technician had a measurement error of negative 1.6 degrees Celsius. And the sign matters when you're calculating error. Error can have a positive or a negative value. And our answer has to have one decimal place, because when you're adding or subtracting, your answer has to match the number of decimal places with the measurement with the least number of decimal places. And since both our measurements have digits in the tenths place, our answer needs to have a digit in the tenths place. So that's the answer to the calculated error. Now let's move on and calculate the percent error. The percent error is given by the following formula. We previously calculated the error, so we can plug in negative 1.6 degrees Celsius, where we see error, and that's going to turn positive because of the absolute value. And that goes over the accepted value, which is 125.7 for the boiling point of octane. Multiply by 100 to turn that into a percent. And we get 1.27 and so on. In this part of the calculation, we're only multiplying and dividing. So our answer has to have the same number of sig figs as the number with the fewest number of sig figs, which is 1.6. So we need to round our answer to 2 sig figs. So the percent error the textbook is looking for is 1.3%. Now let me explain why I disagree with this. There are many substances that have boiling points closer to zero. And I'm just using boiling point because that's the context of this problem. You can be measuring the temperature of anything. Now consider what the percent error would have been had this technician was 1.6 degrees off, measuring a substance that has a boiling point of 1 degree Celsius. So the technician, having the same magnitude of error, would have a percent error of 160%. Do you smell something fishy? And the reason is that we're using the Celsius scale. The Celsius scale arbitrarily sets the freezing point of water as the 0 point. You can even have negative values. In other words, it's not an absolute scale. I mean, there would be no such thing as a percent error for the freezing point of water, because any error would be undefined. But these types of problems are not uncommon, where teachers or textbooks ask you to calculate the percent error, and they're giving you measurements in degrees Celsius. So how do we solve this problem? To solve this problem or any other problem where you're given a scale that's not in an absolute scale, is to first convert it into an absolute scale. So for this problem, we need to convert Celsius into Kelvin by adding 273.15. And here's what that would look like. Truth be told, you're not going to get a question like this on one of my tests this early on in the course. Any problem related to percent error are all going to use measurements in absolute scales, such as distance in meters, mass in grams, time in seconds, where there are no negative values. So I hope that helps whoever it helps.